Can you hear me okay?
Yeah.
Perfect. Awesome. Well, Luke gave me, I think, a better introduction than I could give myself, so thank you, Luke. But in case we haven't met yet, my name is Lowell. I usually hide in the back right about there, but today I'm standing up here. Roles are reversed. I thought I would kind of introduce a little bit of my background, kind of how I got into fish as a hobby. I've kept fish on and off throughout my life, a few times throughout childhood, adolescence, but nothing serious, not like this, not like what we do now. I didn't get into keeping fish seriously until I was an adult, until now maybe 4 or 5 years ago. What got me into it was failing at gardening. I was trying to grow a small vegetable garden out back, and I live here in Sacramento, and as you probably know, in the summers it gets really, really hot in the middle of the day, right? So I found that some of my plants, if I wasn't actively standing there at 12 o'clock, 1 o'clock, watering them the whole time, I would come home from work and they'd be wilted and nearly dead. And I was getting real frustrated about that and complaining to friends and family about it, and kind of jokingly saying, I'm going to bring this operation indoors. I'm going to set up some grow lights and I'm going to have like an herb garden or a few vegetables or something. I don't care what it costs, I'm doing it. And I got a brother that sent me a link, picture of one of those silly little tabletop grow an herb with a betta kit, right? Little mini aquaponics. Anybody been duped? Okay. Me too. I saw that, I didn't buy one. I basically said, hold my beer, I'm going to do this bigger. And I built a large multi-tank contraption, circulating water through multiple tanks that was going to be an aquaponic vegetable setup. Never got it completely finished, never planted a single seed because I was distracted along the way. So I needed fish. I needed fish to make waste, right? And I thought if I'm going to keep fish, I want to keep a cool fish. And if I'm going to keep a cool fish, I want to take really good care of it, make it happy, give it some friends. So I started reading. I got into the internet and just went down the rabbit hole. I did eventually get some fish, but just, I don't know, a few weeks, couple months later, I had an accidental spawn. That's what gets us all, right? There were some Danios, and I had to move them to another tank because I didn't know how bulkheads worked, and I had a leak. And I just found a little tiny free swimming fry darting around the tank, and my mind was blown. I didn't know that was a thing you could do. I didn't know you could breed fish. Frankly, at that point, I was hardly out of knowing there was anything else other than mollies and bala sharks, right? Like the PetSmart Petco stuff. I just didn't know you could breed fish. And I was captivated. I looked at those little fry and I said, this is it. This is my life now. This is all I will do. And now I'm here. This is my life now. Okay, so I breed fish. Don't keep any display tanks anymore. I gave up on that. I've got, 22, 23 tanks, and they're all for breeding. Okay. 3D printing is also something I've done more of in my life. That came earlier while taking some engineering classes in college. I got into 3D printing and also 3D designs. That was probably 8 or 9 years ago. And one day I got a bright idea and thought I'm going to merge the two. I'll explain when that came. So 3D printing as a topic is a little bit dense, a little bit dry, but have no fear, we're not going to get too deep into the science of 3D printing. We're going to give you a little introduction to what it is. Most of this, though, is about designing something. 3D printing just being a means to an end, right? A means of manufacture. And at the end, if I have succeeded in convincing you to go buy a printer, I'll tell you a little bit about getting started.
Question.
Yeah.
What was your first printer?
I'm going to show it to you. Okay, what is 3D printing? At a high level, it is a means of additive manufacture rather than subtractive. This is important. It is not important, but it's kind of a fun detail. Analogy for this I would use is building a house would be additive, carving a cave out of the side of the mountain would be subtractive. So other forms of additive would be like injection molding. Subtractive would be milling out a part from a block of aluminum, for example. Okay, 3D printing is additive. And there's several ways to accomplish 3D printing. We're going to talk more about resin printing later, you and me. But what I do is called FDM, Fused Deposition Modeling, and that's kind of the most common at the consumer or hobbyist level. And in FDM, you are making a part layer by layer, one deposited on top of the other, and each new layer sticks to the one below it because it's plastic, and each new layer comes out hot, liquid, and it just melts together, right? That's the idea. In more practical terms, let me get my laser. We have a roll of plastic, specifically a thermoplastic. We'll talk about what that means later. We feed that into a device called an extruder, which is a very precise electric motor that shoves the plastic through a hot nozzle. They call it a hot end in the hobby. Very small, it's like 0.4 of a millimeter, this one is. And then it squirts out that plastic onto a build plate and makes something for you. Here's what that looks like. At first, it's like you're painting a little cross section of the part, just onto the build plate. A few layers high if you can't see, just gets taller.
P1S.
Growing. Okay.
Is that a P1S?
It's a P1S. And we're done. We made something. That was a major time lapse. That took about 4.5 hours, but I print slow. Who said P1S? I forgot to ask. How many people in the room own a 3D printer? Oh, all right. Okay. So here's the deal. I need your help. I need your participation. Or lack of. If I say something wrong or incorrect about 3D printing, just pretend like I was right. Thanks. Okay, so this is the fun. Anything that you can design within reason, there are limitations, you can translate into a physical object made of plastic, and that's awesome. Lots of potential there. So, if it's so great, why don't we all have 3D printers? I think this is an example of a little bit of retro futurism, flying cars. You know, why don't we have the Star Trek food digitizer and 3D printers making everything we need? Well, I've got a few guesses. First, we only need so many cell phone stands and bootleg Warhammer figurines. To be fair, I would venture to guess that 99% of everything that has ever been 3D printed in someone's home has been junk. That's just truth, I think. Number two, 3D printed parts are both in perception and really reality, and a little bit weaker, a little bit more fragile, less polished, less smooth, compared to something like injection molding. It's just not quite as refined and consistent. There are many flaws and downsides, but I don't want to undersell it. They're still good. And I brought a couple of things today that I would invite you to come and pick up and hold and feel later, so I can show you. They're pretty good. They're pretty solid. I should mention, when I first got into, 3D printing back in the day, I was designing airframes for drones, which are under a lot of mechanical stress. So strength is something that you build into the design and the print settings. So don't think them weak. They're just never going to be as smooth as injection molding. Okay, most people don't have access to the software or the know-how to use it to make their own parts, so that when you need something, you can just mock up the model and print it. So number one, that's a trick, that's a trap, that's false. You can actually never have too many Warhammer figurines. But number two, half true. Number three is really where I lay the blame. I think without being able to make your own parts, you are relegated to the junk in number one. And that's the limitation, and I'm going to talk about that a little bit at the end, how you can get into it, making your own parts. So how can 3D printing help a fish keeper? So here's my rhetorical question to you. Since you all have fish tanks, if not fish rooms, is there any other hobby that you know of that is in more constant need of just the right piece of plastic? I would say no. You need something to stick these two things together, connect these tubes, or hold a thing just right here. And being able to make something that you design would be incredible for this hobby. So to give you a more specific example, I want to show you something that I made that I've been working on for the last couple of years, which I think is a good example of, not a limit, but to me about as good as it gets. Kind of complicated, really impactful, creating a useful piece of equipment that's a part of my everyday activities as a fish keeper and a fish breeder. This is, I think the easiest term would be breeding box, breeder box, right? We're all familiar with that. Okay. Very important to me. So let me start. This is a non-rhetorical survey question. What are some benefits to keeping fry in a breeding box or some kind of a little enclosure? Yes.
Parents won't eat them.
Parents won't eat them. Amazing. Give me a couple more.
Easier to clean up.
Clean.
Easier to clean up the debris.
Uneaten food, mold, that kind of thing. Perfect. Yes, sir.
I would say target feeding or easy access to food.
Easier to feed them. Absolutely true. One more.
If like the parent eats really small food, the parents will eat the food, and
That's actually a new one, and that's entirely true. Less competition for food with adults. Okay, 2 more. Yeah.
Easier to count how many you have.
Yep, absolutely. Here's my list. Keeps them safe from the parents, from other adult fish that might eat them, keeps them from getting sucked up by a filter, makes them easier to target feed, like you said, right? Keeping them in a small space so that they don't have to go hunt down the food when it's swirling around the tank as a whole. Easier to keep track of their number and their health, right? Track any mortality, kind of, are you succeeding or failing? Very helpful. Oh, last one. When they're all in a small container of some sort, when it's time to move them all to another tank, maybe a larger tank, you can just pick them up and dump them out somewhere. Yeah.
Another one that's very important for me is it's easier to keep the bigger tank that they're in some sort of stable temperature. And if you try to keep them in little tiny things, it's really hard to keep those constant environments. So this is a nice feature.
Also, absolutely true. Okay, more questions. What makes a good enclosure for fry?
Clean water.
What qualities of the container itself are critical?
You want it to be permeable. If you're putting it in another tank, that way water can exchange in and out.
Okay, exchange of water, good.
If it's sitting inside of another tank, not flipping over.
Okay, being stable, that's good. Yeah,
Soft edges to prevent injury to fry.
I like that one. Any others? Yes. Hi.
So that they hide, so they don't wash out.
Okay,
They-
keeps the fry inside,
They
right?
don't escape, yeah.
Very good, yeah, I agree. Again, here's my criteria. Keeps the fry inside, keeps them from escaping. It either allows water to kind of passively exchange into the enclosure, or it actively facilitates that circulation with maybe some kind of a pump. Small volume, right? If volume wasn't a factor, then just letting them loose in a tank would be fine. Small volume, I think somewhere under a gallon is probably right.
I wanted to know about the warranty thing on the previous.
Oh, you can't get them in there. Yeah, you don't give them phones. Okay, last one. This is a little bit more obscure, but I think important when you're really getting into feeding tiny fish. Whatever container they're in, you want to, if you give them a small food, you want that food to stay in the enclosure, right? Imagine feeding fry powders or paramecium, vinegar eels, or what's the other one, microworms, right? This really tiny stuff. You don't want it to just flow right out of the box, but the fry are trapped within it, then they can't eat it. They don't get any food. So generally, you want the food to stay in the box. Okay, so I started, the first kind of enclosure I used was one of these. I think they were originally Marina, now they're owned by Fluval, but the classic hang-on tank breeding box. All right, so let's run this past that checklist for what makes a good enclosure. Small volume? Yes. Circulates water? Yes. Prevents fry from escaping? No, not at all. Not as it comes out of the box. Retains food particles, kind of, sometimes. Notable issues in my experience, that outflow gate does not stop fry from escaping. Here's what it looks like, just out of the box. Those gaps in the outflow gate right there, they're very large. I don't know many fry that's actually going to stop from escaping. The water flow is too turbulent, too rough. Yeah,
Can I give you one other flaw with that?
please.
Once that little grate clogs, then it goes to this spill over that you
Yeah.
have in the big slot, and then all the babies wash out.
And if you don't have it mounted right, it comes out the front of the box.
That's right. Yeah.
Not that has ever happened. Okay, here's what the water flow looks like. It's kind of like a normal, medium-high operating pressure. Maybe this doesn't seem like much to you, but when your life revolves around tiny, tiny little sensitive fish, this is barbaric, this is atrocious, this is dangerous, right? I hate this. So the natural thought would be then turn it down. Well, it doesn't turn down very well. You can adjust higher pressure, lower pressure. You have a range that it can operate at, but at its lowest, it will stop moving water before it reduces that turbulence. So for example, I say low pressure, but to me, this is a lot of air. This is what you get. Dead fish. Right? That's not going to be very good for us. To get this high pressure that I showed you earlier, this is how much air that it takes. And this is just an absurd volume of air. Okay, last little nitpicky issues with it. The bottom of that uplift system is not covered with anything. There's large gaps in the bottom, so any mulm or debris that's passing through the water column will get picked up by that uplift and it'll end up accumulating on the bottom of the container. So if you have Corydoras, for example, that are hanging out on the bottom. I know we like mulm these days, but there's a limit, right? You don't want them living in junk on the floor, so I don't like that accumulation. And also you can't have a tank lid when you're using a hang-on tank. So a few things that I did to try to make the best of a bad situation. Number one, keep the fry inside. Use a piece of foam to block that outflow gate, which works pretty well. Not perfectly. I would say I think this foam that I'm showing you here is probably large enough. I've had fry go through this. Like Danio fry, those really small ones. They will pass through that porosity. You can go finer, but this is such a small surface area that it clogs up almost daily. And if you're not paying attention, then you're sending water over the overflow or, out the front of the box. More sponge. So I got a hold of these little pre-filter sponges, and I would cram those over the bottom of the uplift, and that would do a pretty good job of keeping mulm from getting picked up. This is kind of a bigger one, the flow issue. So I did away with the air uplift entirely, and I went to using an electric pump. So fun fact, if you just are trying to make do with what you have laying around the house, if you have a power head with a Venturi attachment and a valve, if you throttle the flow down, you will force water out the Venturi instead of pulling air in. Looks like this. That's pretty nice, right? I like that. That's what I want. That's kind of the gold standard for me for nice, smooth, consistent water flow into the container. But it's pretty inconvenient, right? So we solved a lot of problems, but having one power head per breeding box or doing a big manifold system to me is just a little bit too far. Difficult to replicate. Next I use these, the German breeding ring. Anybody, show of hands, German breeding rings? Yeah, they're awesome. This was my next attempt, and these are really good. These, rather than being made by Fluval, these were made by hobbyists, that breed at least quasi-professionally, and these have a lot of improvements. They hit all of our criteria, and they're really good at retaining food particles, retaining the fry. If you haven't dealt with these before, sorry, let me be a little more specific. So, foam block up top that makes it float, clear section of tube. The bottom of it has a very fine mesh on it, and that's where the water that flows into the thing flows out. So no fryer escaping. I think paramecium will pass through it, but fry will not. And what do you call them? The worm stuff, microworms and vinegar eels. What's the name for that? Nematodes, thank you. You've had nematodes go through?
Yeah.
All right. It's getting weaker, but they're very cool. Okay, they meet most of the criteria. Some things I really like about them. They float, so they don't keep you from using a tank lid. The dimensions favor width over depth, which is, at least to me, a good thing. I think generally a little bit more breathing room to spread out, for food to spread out within reason is good. Depth I don't think is usually important. There's just one exception where I think for fry, that depth can be really helpful. Any guesses what that is? Okay. In my experience, fry that only want to eat out of the middle of the water column. They don't want to eat off the surface and the bottom. The deeper the container is, the farther food particles fall before landing somewhere the fry won't eat it. So that's about it. But I've only dealt with one species that really ate like that, and not enough to design for. Yeah, fry aren't leaving. The uplift, this is another air uplift circulation system, and it's naturally filtered. They come that way. I love that. The water flow is a little bit more gentle, but not perfect, okay? And quick obligatory note, these are made by hobbyists that we like and respect, so I'm going to criticize it, but don't get me wrong, these are wonderful, and I still recommend their use. Okay, issues. To me, the water flow is still too turbulent, and even though the uplift is a lot more efficient, I still think it takes too much air to run. So here's what it looks like at a medium to high pressure. Okay, here we are at kind of a lower pressure. You can see it's a lot better, but still kind of struggling, still kind of inconsistent, and it gets hard to tell how much water is actually moving when you get those thin bubbles. You don't get to see an outflow, so you don't see the volume of water leaving the container until it's on the bottom, right? At the very least, it makes me nervous, and I still don't like the turbulence. My real gripes are more about how it's made. Those kind of bug me. So it's a little small, but that's minor. I don't like that it's made out of styrofoam. The key structural component that holds everything together is styrofoam. And when you're working with these, you're often, taking them apart, putting them back together, setting them up on different tanks. And when you do that to styrofoam, repeatedly compressing it, eventually the parts won't grip anymore, right? They'll slide right out, they'll fall apart. Like I have a couple in a box that I would have to tape together to make them work, and that I found disappointing. Also, when you're done using the German breeding ring, what can you do with the fry other than release them into the tank that they're sitting on? If you pick them up, all the water drains out. Some people are okay with, exposing the fry to air. Dick Au pours discus fry through a strainer, which just blows my mind, but he can't be wrong. Let's just say I don't like it. I don't like doing it. And with a German breeding ring, you got to put a bowl under it of just the right shape and lift it out, or else you lose the water. So I kind of don't like that. So one day I was getting frustrated, and I remembered that I had a 3D printer in the closet, and at one point in my life I knew how to use it, and I thought, I should try to make my own, just see. I've got gripes, let's see if I know how to make one better like I think I do, right? Kind of a put up or shut up moment. And a few weeks, maybe months later, I forget, I made something. These are the requirements for the design. This is what I wanted to accomplish. Sorry, it's a little long here. So, wider than it is deep. I wanted it to float. I want it to hold water when I take it out of the tank, not drain out. I want that filtered intake. I want fry to stay inside. I would like to have circulation that has the quality and the smoothness of that electric pump that I showed you, but it's provided by air uplift for simplicity, portability. I want it to be able to run at a very low flow rate for sensitive fry. For example, rams. My benchmark for whether or not my own design would work was, could I raise baby rams in it from free swimming, from the very beginning when they're the most sensitive. No tall order, right? Okay, so to the lab, got the software reinstalled. A couple weeks, maybe a month later, here's what I came up with. This is not exactly version 1, but it's close. And here it is running.
That's cool.
Yeah, it's little bubbles right there. Water's moving. So what did I accomplish? It's wider than it is deep. That's great. It holds water for a while. It's got a filtered intake. So I did an uplift system. You can see air tube right there coming into the side. And I got a tube sticking out the bottom, just a simple slip fit into the bottom of the container, which I covered with an intake sponge for a Fluval Edge kit, because they're everywhere. You can buy them. There's aftermarket, name brand, whatever. They're just popular. It's easier to find this sponge if you're looking. And I thought, since I already have one sponge that is a key part of this, what if I just use 2 of the same sponge for the same thing? Use one again for the outflow. So I designed the outflow to fit that same cylindrical tube style. I wanted to, if possible, reduce DIY and just pull the thing off the printer, shove a couple sponges in it, and be ready to use it. That's what it looks like. It's just a cylinder that the foam shoves into. Water spills over the edge and straight down out of the enclosure. And I got my smooth circulation. I'll tell you about that. So what typically happens in the life of a bubble? We release it underwater, it rises to the surface, maybe travels a short distance over the top of the surface, and then it pops. So what I tried to do was pack that distance, kind of coil it into this structure on the left here. Between that and the bubbles colliding with each other and with the walls of this structure, they don't last very long as they come out of here. That's what it looks like. So all that turbulence, all that chaos, all those evil bubbles are destroyed. And what comes out of 2 outflows here is a very smooth flow of water. Yeah,
Why not just a simple spiral?
try it. Go make one. And I got my low flow. This is where it gets a little bit more complicated, but also fun. Okay, so uplift pumps. Lifting water up a tube. I think there's kind of 2 ways to look at it. There's kind of the tangible, more intuitive interpretation that I think we probably share, and then there's the theoretical. So here's the intuitive, at least my intuitive interpretation. You have a vertical tube, It's underwater. You release a bubble at the bottom. That is, let's say, most of the diameter of the tube. Okay? And the bubble rises because there's nowhere for the water above it to go, but up, water is shoved out the top of the tube. Fair enough? Close enough? Okay. Kind of, but not really. Is that how it actually works? In theory, this is how it actually works. It's not about the bubble blocking the tube and then forcing water up. It's about creating an air and water mixture. That's the part that actually matters. So this right here, just imagine you have a column of water in a tube. As soon as you start releasing bubbles, the net density of that column of water is lower than the water below it and above and outside the tube. Right? Now it's subject to buoyancy. This dense water wants to displace the less dense water, and it is forced up and out. Bubble size doesn't really matter there. All that matters is the mixture and the resulting density. And we kind of know that. That's something you can do with sponge filters. You can put an air stone in them and you got a bunch of tiny bubbles instead of very large bubbles, and they work better. They move more water. We kind of know that from experience, right? So I didn't try to do this. I did not try to do tiny bubbles, even knowing that they kind of move water better and in higher volume. The reason I didn't do that was because, for one, making tiny holes would be difficult for a 3D printer to accomplish consistently. The other is, in my experience, any submerged portal for pressurized air underwater will eventually clog. It's like a law of nature to me. And when it does clog, I wanted that to be easy to unclog. What I tried to do seemed to fit a little bit better with the intuitive rather than theoretical interpretation of how these work. I just tried to accomplish as much as I could with a single bubble at a time rising through a tube. Okay? So we can kind of assume that a tiny bubble is not going to accomplish much. It's going to rise up, but the water above it is just going to slip down the sides and not be lifted along with it. Right? Too large of a bubble, also not going to work very well. If you have too much pressure, it'll actually blow out the bottom of the uplift and you're not moving any water at all. So somewhere in between the two is a Goldilocks zone of the perfect bubble. And to figure out where that was, I used no math, no science. I just tried stuff until it worked. I made a bunch of these structures right here, also 3D printed. They're just two tubes next to each other. Down one side would go pressurized air to a tiny opening, and I would keep changing the size of this opening, and then it would go into a little simulated uplift tube, also with a diameter that I would keep tweaking. And I just tried different diameters for the uplift tube and the opening for the air bubbles until I found a combination that worked. And my conclusions, what I found was the reason those other uplifts from the commercial models, they don't want to move a small amount of water, is they're just too wide. That's like the single most impactful variable in how much water is moved in an uplift tube, is how wide is the tube and how much water passes through it. So I ended up making mine narrower, much narrower than theirs. And then beyond that, there seemed to be some sweet spot, some ideal ratio between the diameter of the uplift tube and the diameter of the aperture for pressurized air to come out. I think it's like 2.5 to 1, if I recall. Okay, and here it is, working at low pressure. That is very, very little air, but you can see it's still flowing consistently. As long as there is water in these channels, it is flowing. This is really gentle. This is what I wanted. And it floats. Kind of, at least for a while. So, fun fact about 3D printed things, kind of a double-edged sword. They're mostly hollow. They're a little bit like IKEA furniture. You see this shape right here? This is what the inside of a 3D printed part might look like. You do have solid shells on the outside, but the inside is some kind of a grid pattern in there. I would say 25, 30% solid, 65, 70% air. So they naturally float. Yes, ma'am?
Why do they have those like X's?
When you're doing this, you get to choose what that pattern looks like. You can do octagons, kind of a honeycomb thing. Science has determined there are certain ways to efficiently fill space, and that's one way.
Stronger?
Yes, it does make it stronger. This is a pretty strong pattern. Yeah, there are stronger and weaker patterns. Okay, flotation really didn't work out very well. There's a couple problems with 3D printed parts and flotation. One of them is it's very difficult to make them consistently watertight. There are tiny little holes where water can get through. And another one, when you're working with what I think is the most common material, it's called PLA. We're going to talk about materials in a little bit. PLA is hygroscopic, which means it actually absorbs water from the atmosphere. And my suspicion, I don't know this, but my suspicion is that it will sweat that water back out into the internal cavities, even if there's not a leak, and they'll eventually fill up with water. So I would say that my floating models, they would start to list after a few hours, and a couple days later they would be in the tank. So I started working on a new design that would sit on a ring of PVC, which would not take on water. And I did the best I could, but I was kind of wearing on the floating thing, yes.
So how does the water not get like sucked in by the filament?
It does. It does get sucked in, and that's the problem. Okay, there's things you can do to ameliorate this problem. You could seal up the outside. There's a lot of things you could do, but they're a lot of work, a lot of effort, sometimes costly. And I wanted these to be simple and easy to replicate, not just by me. Okay, so around this time, I showed these couple of early designs to the internet, and the reaction was positive, stronger than I expected. There seemed to be a lot of interest in it, and the responses I got typically fell into one of three categories. The first and most common was, can I buy one? Which, no, I did not sell any. A lot of people wanted the files so that they could print their own on their home printers, and I said, let me keep working on it because I'm having some issues, but yes, I'll send you the files. And then the last was, can you make one that doesn't float but instead is fixed to the tank? See, at the time I thought floating was great, I wanted to use a lid, but really, overwhelmingly, people wanted them to be in a fixed position at the top of the tank. And I said, okay, I will do that. My priority kind of changed at this point from making something for myself. I saw an opportunity. I was like, okay, with doing this, we might be able to actually fill a gap in the equipment that's available to us as breeders. I should do this. I should put some effort into making this something that the community can use, and it's got to be good. So I kind of had to listen to people's feedback on it. So back to the design software. More time later, this is approximately version 2. So I added, instead of the flotation ring, an expanding and contracting rail system that would sit on the rims of that standard tank rim style. Think like an Aqueon, an Aquarium Masters, or whatever it is you buy at PetSmart. I forget that one. I always forget that third brand. And the rails are long enough that it can fit. I was aiming for 10 and 20 gallon tanks and everything in between there, all the common sizes. 20 gallon longs in particular, very popular with breeders, right? I also redid the uplift instead of the slip fit that I showed you earlier. Instead, I went with kind of a twist and lock design here, and then that didn't work out so well, and I eventually went with making them threaded. And I had to do that because I had to eliminate what are called fine tolerances. So slip fit, where you just have, think like a PVC pipe and a joint connection. It just slips in there very snugly, and it can actually be difficult to remove. Right? Those have to be just the right dimension for it to do that. And the problem with 3D printing is if I make a tube and it's exactly 0.5 inches in outside diameter, and I give the print file to someone else and they have a different printer, different print settings, there's no guarantee it's going to come out 0.5 on the dot. In fact, it's most likely not. So to make this something that can be shared and printed by many people, it could not rely on any particularly fine dimensions. Ruled out slip fit. Having the trays, I've taken to calling them trays now, having them at the top of the tank also introduced an issue I didn't have before. Now the distance between the outflow of the uplift and the tank water level was variable, and water could be lost to evaporation. I also gave up on not interfering with a tank lid, right? So a tank without a lid, especially with sponge filters or air uplifts in it, they lose a lot of water. And as that water level drops, the function of the uplift suffers. Oh, yeah. Right? They don't want to lift water that far above the natural water level. So I had to make some changes. That's where air used to go in. Instead, I moved it actually to the uplift tube itself, and I lengthened the tube because the distance that you can lift water above the natural tank water level is, let's say, a percentage of the total length of the uplift tube. So the longer the tube, higher it can lift. Makes some sense. And it's still not perfect. This is still a threat to how well the thing works, but I would say you can get to where the water level is down, pretty close to the bottom of the tray, and it'll keep running. Not well, but it'll keep moving water. Another issue I ran into was flow concentration. This whole time, every time I'd make a new version, I would try to run some fry through it and make sure it actually worked. So an issue I had with this one was flow concentration. I'll explain what that means. So this little red layer right here is about how thick the layer of water was that would spill over the edge of that tube that held the foam before it passed into the foam. Picture in your minds, because I'm sure most of you have done this, you've got fish or a little fried in a dip and pour container and you're pouring that out. They don't really feel it until they get close to the edge, right? And the closer they get, then they start panicking and trying to swim the opposite direction, right? Because the flow pulling them towards the edge and over it is getting more and more intense the closer they get, right? It concentrates. You kind of visualize it with this. And so a fry out here doesn't even feel it. The closer they get really pulled over that edge. And that was going on with this outflow style. So what I found, after thinking about it, was if I want to keep fry safe from getting pulled into the sponge, and I should clarify, I've got the sponge there to keep the fry from passing through it, but the flow could be so strong that it would trap them into it, or with a coarser foam even into the pore of them, and it would kill them, right? That's worse than them flowing out into the tank, because at least then you've got a shot at turkey bastering them back out. This way we just kill them. So to keep them safe, the foam has got to, just shattered my train of thought for some reason. Water can't concentrate until inside or behind the foam, not in front of the foam. So to accomplish that, I moved the drain to the back, behind the foam, instead of flowing out the bottom. I also lowered the depth of this tube that held the foam so that more surface area was exposed. Again, less concentration still. And this was working pretty well. I would say it met my needs. I was pretty happy with it at this point. So I wanted to seek some expert opinions. I don't know why I thought this would work, but I kind of did a Hail Mary pass. So who in the room is a fan of the Aquarium Co-op team? Knows them. Yeah, good number. That's great. So them. I took a couple of these, packed them up along with a bag of wild-caught Reese's, which passed for a kind of, yeah, thank you. You know what that's for. Kind of a currency up in Seattle, apparently. And I sent that to the co-op team, and I just threw a letter in there that just explained what they are, how they work, what I at least hoped that they did, and really nothing more than that. Just said, enjoy. I thought you might like these. Here's an email address if you ever need anything. And I didn't expect to hear back soon, or maybe not even at all, but 4 or 5 days later, my phone lit up. I was just sitting at my desk at work, and I saw that guy, Dean Tweedale. We all know him, right? I know. So I saw his name, and a few minutes later, I recovered consciousness, and I read his email. And what he said was, I got the trays. I'm keeping both of them because Corey's not breeding right now. They look nice. They look like there's a lot of thought put into them, like they probably work pretty well. I'm going to try them out. I'm going to put them in my fry tank and put them through their paces and see how they do. And if you're open to it, I think I could provide feedback to, take them from good to great, maybe even make them a little bit better. To which I said, yes, absolutely. You can test them and tell me how to make them better. Because I don't think there's anybody on the planet in a better position to test out a fry enclosure and tell whether it works, right? He's kind of the master in more than name only. So he did. He tested. We went back and forth for 6 to 8 weeks, making revisions here and there. And here were the things that he asked for. And these are kind of least important to most important, mostly. So he said make a cap. He was working with a species that liked a lot more flow than I was working with at the time. So he had the flow turned up quite a bit. And up at the top of the tank, that gets kind of messy, a little bit of splatter. So he said make it a cap. So I did. Lowered the level of the uplift just a little bit to accommodate a nicely fitting cap that would sit on top. He also asked for pins to kind of clamp onto the rails and make them a little bit harder to collapse. The problem is, when these are sitting on a tank, the rails, they have an angle on them that makes them grip a little bit like a clothespin, so if you're just turning the thing over in your hand, it won't fall out. But if you bump one on the edge of the tank, it will collapse and then it'll knock the tray into the water, and as we talked about earlier, it'll float for a while, but it's still not something you want. So he asked for a clip. He demonstrated with a little piece of wire, but this was kind of what I came up with. It was just a shape to shove onto the edge where it meets the tray body, and it wouldn't stop you if you were really trying, but it will definitely provide enough resistance to keep you from knocking the tray into the tank, just accidentally. With these clips, I also saw an opportunity to do something I already wanted to do. One of the downsides of the really smooth, calm water flow is I would accumulate protein films pretty bad. And you're putting a lot of protein-rich food in to feed fry, you get that little oil slick on the top of the water, right? And one of the ways to cure that isn't draping paper towels on it, is to have a little bubbling. Just a very slight bubbling will take care of it. So I was looking for some way to have an additional air supply come into the tray and take care of that for me. So I made another version of that clip. It's just a tube to mount a like a Lee's 3/16 thin wall section of rigid tube that you could pump air through. So this was the big one. This one hurt. This one was very difficult to overcome. You wanted to completely rework the outflow. So I made a serious tactical error when I sent these to Dean. I wanted to use the nicest materials I could, and I was also thinking about very small fry. So I used what was the name brand Fluval pre-filter sponge. And those happen to be, as nice as they are, very, very fine porosity, which would be great if you were dealing with something like Rams. Dean breeds Rams, right? He's gonna love it. Now, when he got the trays, he put in them the worst thing you could possibly put in those trays with that foam, which is wood-eating plecos. And they clogged, the foam clogged immediately, and it was overflowing. So, you know, in his experience, many of you probably know his fry system. He has a horizontal slot drain system blocked with foam, right? So his recommendation was, these are clogging, why don't you try this? Do a horizontal slot. And after we'd already been working on some other problems, I think he was kind of realizing the potential of being able to dictate an idea and just have it materialize, because he's used to modifying, and you know, with a 3D printer at hand, we can create from the ground up. And he started getting creative, and he said, what if you build some kind of a cage enclosure on the outside of the tray to hold the foam, so that you're keeping the dirty sponge farther away from the fry entirely? It was very difficult to accomplish, but this is kind of, after many revisions, my interpretation of what he asked for. Just a cage to hold a foam block. One thing I really like about this, because I'll be honest, I was pretty attached to making the cylinder thing work. What I really like about this was you just need a rectangular piece of foam, and anybody can cut that out of what they have lying around. Those Fluval Edge sponges we can find everywhere, but in South Africa, they don't have them. And I know that because someone just emailed me saying, where do I get them? I want to do this in South Africa. So I like that you can just cut them out of whatever you have laying around. Lots of surface area, probably just slightly more than the tube. This actually reintroduced that issue with flow concentration, because you can see the water is hitting the sponge just like it was before. So I had to play with the heights of where the water drains out here on the back of the cage to create an area that would put the flow concentration behind the foam rather than in front. It was really hard. It took a lot of work, but eventually made this work. He also asked for emergency overflows, because even he, when he goes out of town and he has someone watching his fish room, he told me occasionally the sponges will plug up and water would come over the side, and sometimes even out of the tank entirely. And that's not good. So have a couple of little cuts on either side and above. Water will just spill out over there if it does clog. But this design is very difficult to clog. Last one, this is another small one. He said print in white. I started in white, you probably saw that, but I moved to gray after a while because, frankly, they show up better on camera. White with, filming lights on top of it, it just looks awful. Gray looked a little bit better. And also they tended to accumulate algae, right? It's a white object in nutrient-rich water, probably under an aquarium light, which are grow lights, really. They grow algae, and 3D printed parts, they have a little bit of a rough texture to the surface, and so it's not like acrylic where you can wipe something off of it. When they get dirty, they kind of stay dirty unless you soak them in bleach, and that's an ordeal. So he said print in white, and the reason for that was maximizing visual contrast, letting you see the fry, see their size, their shape, their color, which means health, and he's absolutely right. It is the right thing to maximize how well you can see the fry. So I make them now in white, and the answer for how to clean them is don't get them dirty in the first place. And here you go. After all those revisions, this is kind of close to the finished product. It's working. You can see that little bubbling coming in here from the side. There's the uplift running in the back. There's our drain. And all throughout the middle are the rams. The little ram fry. So it works. I was very happy about that. When it was all done, I did send a few of the finished ones to his, but his had a special detail. I hope a few of you get this. In the rails, I printed a blue screw.
Yeah.
Thank you. Okay, for the rest of you, I'll explain. He is famous for having an immaculately planned and organized fish room, but in one spot, he has a lone blue, looks like a ceramic screw that looks like he kind of ran out of the black drywall screws he should have been using and just used what he had. That's not a Dean thing to do. And I think it's our job as his friends and fans to never let him forget it. So this is me doing my part. So since that time, I've made some small revisions to the design, but nothing really worth talking about. Mostly it's just been creating different sizes and shapes so that they fit on more tanks. I do now distribute the print files, and because of that, they're all over the world, probably most of the country by now. I started shipping these about 2 months ago, and in those 2 months, I've shipped them to 23 states, so they're all over the place. And I hope improving people's fortunes with raising fry all over the world. A few other things, much less impactful, but just to show you some of the crazy things that can be accomplished when you can make whatever you want. This is a replacement stand for the Ziss brine shrimp hatchery. The stands that come with them are awful. You can't get your hand under it. So this is a quality of life improvement for me. This is a next project that I feel like attached to, really invested in, is making a nice egg trap with a mesh layer that can kind of slide out like a drawer a little bit. That round object I showed you in the beginning of the presentation, printing in white, that is an attachment that I made that would allow me to use a Dremel as a centrifuge. I know. I said crazy. And last is a sectional angelfish cone. Last night in San Francisco, someone said, why would you want a sectional angelfish cone? So I'll help you with that. This is, I'll call it family planning for angelfish. What if I just want to raise a few angelfish, not 400 angelfish? Then I only want a few eggs. That's the idea. I haven't tried it yet. It's sitting on the shelf waiting to be used. Okay, let's see how we're doing on time.
You've given too much flexibility.
What's that?
You've got too much flexibility.
I know, I've gone mad with power. Okay, so let's say at this point I have sufficiently convinced you want to go get a 3D printer. Now's the part where we talk about how you can get started.
What happens if you have like 6?
I'm sorry?
What happens if you have like 6?
Then your home starts to look like mine. Chaos.
How many do you have?
At the moment, 4.
You probably haven't done that.
Let's see here. So, a few things you need. Obviously, you need a printer. First and foremost, you need a printer. You can work with designs that other people have made, but you can't do without a printer. And a few small tools. I'll show you what I use. So I started printing things 8 or 9 years ago with something much more primitive than this. The hobbyist level technology was a bit more less refined at the time. But this printer right here I started using a couple years ago until about 2 months ago. This is made by a company called Creality. It's the Ender 3. There are many versions, and as far as I can tell, they're all about the same. But they cost somewhere between $180 and $300. They can print objects that are about 8.5 inches by 8.5 inches, and then another about 10 tall. These are, I think, about as good as it gets at the entry level. I'm a big fan. They're easy to work on, easy to get replacement parts. They do a reasonably good job. They just don't have as many bells and whistles. I would also recommend, if you happen to get one of these, getting something called a borosilicate print bed, a very smooth surface. These printers, they come with a flexible print bed that's supposed to be textured and sticky, but it's not that great. Instead, I opt for a smooth, very hard, and perfectly level, flat surface in this borosilicate glass. And then along with that, I use a print bed adhesive. This is a special chemical that gets sticky when it's hot, and it gets unsticky when it's cold. So those 3 together, I would recommend if you were going for, say, the sub $300 range. If you want to spend a little bit more, there are quite a few options, but I can only really talk about things that I've used, or at least I'd like to stay within that territory of things that I've used, and I have used these. Like you mentioned, this is Bambu Labs P1S. There is a nicer version than this that's almost twice the cost, but unless you're making something in different colors, you don't need it. You have the X1C?
Yep.
Yeah.
2 of them.
I think this, if you're printing in a single color, I think this is as good, and it's $700, which is money that you have to think about. It can also print larger parts, more like 10 by 10 by 10, a little bit bigger. It has a flexible and textured print bed that comes with it that is excellent. So you don't need a lot of other supplies for running this printer. You just need some isopropyl alcohol of a high purity to wipe it down and keep oils or other contaminants from accumulating on that textured print bed. A few other things just to have lying around: wire cutters for cutting the filament, that's really helpful. Maybe a thin metal scraper for popping off parts when they don't come off the print bed on their own. Sandpaper or a sanding block for finishing, maybe getting rid of a little flaw or a rough texture here and there. And straight edge razors, I use those every day. In fact, I use these instead of the scraper a lot of times. You'll also need something called a slicer. That's a piece of software that, to the best of my knowledge, you're never going to have to buy. Every one I've ever used has been free. And I'll tell you a bit about what slicers do. If you were using the first printer, that Ender, the Creality Ender, they have their own slicer, but I'm a big fan of one that was kind of developed by the 3D printing community. I think in conjunction, does Ultimaker make printers?
Yeah.
There's a little bit of an open source element to Ultimaker, right?
Yeah,
I think so. It's really, really good. I would use Ultimaker Cura instead. If you're using one of those fancy Bambu Lab printers, their default software is excellent, and if you want to get one step higher, you can get something called Orca Slicer, which is like they made their own version of Bambu Lab's stock software that offers some additional flexibility.
Wasn't it the other way around where Bamboo copied the Orca?
Orca took the
Or
best
was it
parts of
Cure?
Bamboo Studio and Prusa Slicer.
Maybe it was Prusa. Because I know Bamboo.
Everybody copied Prusa.
That-
Everybody, yeah. That's
Yeah.
another great printer. I've just never used them, but Prusa. Okay, so this is what the slicer does, and you don't need to know this. Once upon a time, 10 years ago, you might have needed to know this, but these days, you really don't. But what a slicer does is it takes a three-dimensional model and it slices it into many horizontal cross segments that are 0.2 of a millimeter tall. And then it takes those slices and comes up with tens of thousands, hundreds of thousands of rows of instructions to tell the printer, go here, get hot to the melting temperature of the plastic, move here, raise up a little bit, move here now while extruding filament at this rate, at this speed, right? Once upon a time, there was a reason to come drop in your own custom code, but you don't have to do that as much anymore. That's still kind of a fun fact about how it works. What is important is having a basic understanding of the print settings. First thing I would recommend is start with the defaults, right? If you were using, let's say you're using Cura for the cheaper printer. If you tell Cura what printer you bought, it will import a lot of defaults that'll work very well for you. And you should kind of try and stay there. Only change settings when you have good reason to believe that they need to be changed, and also good reason to believe that the setting you want to change is going to accomplish the thing that you want. And also change one at a time and see if it did the thing you wanted, because if you just start changing. In fact, there are 100, 200 settings that you can change in how something is printed. You can get lost in there. Just keep it simple, change one thing at a time, see if it works.
Have you tried ludicrous mode?
No, never.
It's insane.
I'm sure it is. So here are a few that you do want to pay attention to, and these are a little easier to not get lost in. These are a little more tangible. Speed is very, very important. How fast do you move when you're printing? How fast are you pushing filament through the nozzle? And on this, I have a little bit of a gripe. The new printers, they advertise being able to print really fast. Printing technology has improved dramatically in the last 10, 15 years, but the materials haven't. It's the same PLA or whatever that we were printing 10 years ago. And you'll never find a filament manufacturer recommending that you print faster than, let's say, 60 millimeters per second. But we have these machines that say they can print at 600 millimeters per second. And technically, you can, but there's consequences. There's costs and trade-offs, right? I have always and will always say print slow. It's just it's a fact of life. A lot of times you do things faster, they turn out poorer quality, and it's true here. The layers don't stick together as well, they can delaminate. I bet the actual crystalline structure of the material does not form as it should the faster you move.
Yeah.
Yeah. So you can get away with it. I print fast too, but not that fast. Extrusion temperature, very important. Too cold and the layers won't melt together as they're supposed to. You can also clog the nozzle, but too hot and it gets saggy. It doesn't hold the shape like it's supposed to. Bed temperature is also important. The print surfaces that we talked about, those go often these days onto a metal plate that heats up. In fact, I would say they should always go on a metal plate. If you go shopping for a 3D printer, don't buy one that doesn't have a heated bed. That should be a standard now. And there's a reason for it that I'll talk about in a minute. But there's a temperature that you want to set that to, and you kind of have to use the manufacturer recommendations for the filament and figure out where that is. Shell, wall, top, bottom surface, those are critical. So I told you the insides are mostly hollow, but there is a solid portion on the outside, and you can choose how wide that is. And that goes a long way for strength and also surface quality. And then the infill percent. Do you want it to be 50% hollow, 75% hollow? That's especially something you want to think about. We're supposed to be talking about 3D printing for aquariums, right? And being hollow on the inside, that affects buoyancy. So let's say you wanted to go home and make a pleco cave, which I'd recommend that you try. You don't want it to float, right? So maybe you use thinner walls so that not as much gets an infill pattern, and maybe you jack up the wall thickness and the infill percentage so that it's mostly solid and it doesn't float. Okay, adhesion to the print bed is absolutely critical. You want your part to stick to that print surface. So one threat to that is warping. These materials, the filaments that we use, are called a thermoplastic. And what that means is that they don't change in volume very much when they get hot, or at least hot enough to be in a liquid state. None of them are perfect. Some of them are pretty close. How did you know that? That's really cool.
Because it says it on a 3D printer that needs to heat up until 200 Celsius.
If you can tell me what that is in Fahrenheit, I'd be very, very impressed. Come back later. You have time. This is homework. Okay. So they got to be really hot, and they don't expand and contract very much, but none of them are perfect, right? They do expand, and the problem is the top layers, they're a little bigger, and the bottom layers have now shrunk down a little bit. They're decreasing in volume, and when they do, they have nowhere to go but curling up around the edges, and now your part's not sticking to the build plate, and that can be not just aesthetically a problem, but it can be a disaster. If the part comes loose from the bed in the middle of the print, it's game over. You're done. So we combat that in a couple of ways. The heated beds, like I told you about, what they do is keep that bottom layer from contracting and then curling. Also, there's an adhesion setting you can turn on in the slicer called a brim. I'm a big fan of brims, which is just a one-layer thick ring around the part. It kind of makes it spread out and stick to more of the surface without adding curl factor from being built up. And those really help. I use brims all the time.
It's 424 Fahrenheit.
You're amazing. Thank you. I didn't even know that. Okay, you need filament. Here's a few common ones. This is not an exhaustive list, but I think most that people in our position would probably use. There are some exotic materials. I just don't think they're applicable here. So, most common is PLA. I think I mentioned that before. It is a plastic. It's technically made from corn. It's very easy to print. It has a low melting point, but it has some flaws. It's not the most durable thing in the world. It's a fairly soft plastic. I have had PLA printed parts melt and deform in the trunk of a car. That's a big problem. It can warp, so heated bed for everything. Everything can warp, heated bed everywhere, but you don't need an enclosed chamber for PLA. Like that first printer, the cheaper one is not enclosed. The more expensive one is fully enclosed. And some of these more advanced materials really helps to have the printer enclosed in some way. Okay, but PLA is easy. Here's the thing we really got to worry about, I think. Is it waterproof? Maybe. We don't know. That's kind of a controversial. I forget what it stands for, honestly. PLA Pro is awesome. I would actually recommend using that. That would be my recommendation for you. Use PLA Pro. It's probably going to last forever. It's still easy to print with. I love it. But for other people, just because there's some outside risk that it might break down in water, I make parts out of PETG or PETG if you're paying by the syllable. It is much harder to print with. It's got some issues with it, stringing, globbing. It's really awful. I don't like printing with it, but there's no doubt that it's going to hold up in water. Yeah?
So, guessing from all of this, you're better off using a printer that uses some sort of filament rather than, say, a resin printer?
I don't know. Frankly, I don't know. I want to learn more about that. People don't. FDM printing is a lot more common than a resin printer, but I would like to explore that myself. I don't know the properties of that material enough to say.
the problem with resin printers are to get the build volume you would need for this, so they are very expensive.
There you go.
Like that average hobbyist resin printer has a build volume of like 3x3.
Yeah, I believe that. So ABS, also not going to break down in water. We have plenty of aquarium products that are made out of ABS, but it's really difficult to print. There's a number, there's a measure of how much things expand when they get hot. I think it's a coefficient of thermal expansion. And ABS is excellent. It's really close to PLA, which is easy to print. The problem is you've got to get it really, really hot. So, that coefficient still leads to more expansion, and it warps real bad. It's tough to print. It also releases toxic fumes when you're printing, so not like you.
So it's not like a good one to use?
Well, it has its place, but it's just problematic. You want ventilation, and it's difficult to pull off a good print with it. So I would kind of focus. My recommendation to you is going to be print with PLA Pro. Unless you want to make something that someday you might sell to someone, in which case I think that that's ethically dubious, and I would go with PETG. You also, if you want to go one step further and make your own stuff, you might need some modeling software. And honestly, there's only one that I can talk about from experience. Right? I learned one called Autodesk Inventor while taking engineering classes, and I now use kind of a trimmed down version of it called Fusion 360, which is now Fusion. That's what this looks like right here. I think it's excellent. I think it is going to have features that are well beyond any of our needs, but along with that comes a price tag. They say there's a free version. I can't really tell anymore. I think they have a poster of me hung up at their office. I don't get anything for free from them anymore. At one time I did, but if you look it up, they say that there's a free version for non-commercial use. I think you can maybe only have 10 projects that you're working on at a time. Otherwise, if you're using it commercially, it's $85 a month. And people say it's pretty tough to learn. I looked up a couple of others just to throw in some options, but again, I don't have personal experience with these. There's another called FreeCAD, which I hear people say has a lot of the same capability of Fusion, but certain tasks that are easy in Fusion are hard and not intuitive to do in FreeCAD. But still, if I just said I am done with Autodesk, I will only be working with free stuff, I think I would look into this one next.
Does it just need DWG files, or what sort of output does what format does the printer take?
Well, they want, kind of the classic is STL, but there are other formats,
okay.
step files, so that newer slicers are capable of importing and working with higher resolution.
But any general CAD program will spit out, like,
I think they do now.
SketchUp, so it has like a free CAD.
I think you'd have a hard time finding a 3D modeling software these days that didn't have an STL output option.
Most of your slicer programs will accept multiple different extensions.
There's one more. This is a browser-based free one, Tinkercad. I just hear this name a lot, and I looked it up. And this one is free, but really limited because you don't get to sketch things out and have as much creative freedom. It's more like you start with a cube and subtract a circle from it. And I don't know. Not a big fan. I think it's pretty limiting. But you could make a PVC joint with it. So maybe something to look into if you want to start with simple. Yeah.
It's like, if you like learning how to do it.
I think this would be a good place to start, yeah.
I'd rather use this.
It's better to start with something simple and get simple results than shoot for the moon, have it be overcomplicated, and then you put it away and give up on the pursuit. So start wherever you're comfortable. So let's just pretend we're going with Fusion. I'll show you what that looks like. Hopefully just to maybe ease some of the scary software. Just a little bit, I want to show you what the design process looks like, and then we're done. Okay, so you start by sketching a two-dimensional geometry, and you get to pick dimensions. This is just a square 1 inch by 1 inch. Then you activate a tool, coincidentally called an extruder. You click on that square and say, add an inch, and now it makes it three-dimensional. Now it's a cube. On the surface of that cube, you can then draw another sketch. This is something called a construction line. This little dashed line in the center here I drew from corner to corner. It doesn't actually form any part of the object itself. It's just like a helper to help you place things in the right spot. So there's little snap to points that form on construction lines, and it might be really helpful if I wanted to put something right there in the center of the cube. Like it will here, a circle. Now I draw a circle. Key in a dimension, 1/2 inch in diameter. Activate the extrusion tool again and click on it, and we run that in reverse. We say -1 inch, and we can cut a cylinder out of that cube. Do that a couple more times on the other faces. Now it's Swiss cheese looking. They also give you these neat tools, chamfer and fillet, to help you smooth out rough edges. You just click the corners, give it a radius, a measurement, like this is 0.075 inches, and it smooths out the hard corners. That's kind of a cool, kind of a complex looking object, right? If I saw that and didn't know any better, I would think that probably took some work to create that model. But in reality, this is 60 to 90 seconds of work. Really, it's not that hard to make simple geometries. So you export that as an STL, for example, import the STL into your slicer, you run the slicer, it makes all those hundreds of thousands of lines of G-code, and then you print it. And now you've got a fidget spinner. It can be. That's it.
Official name.
Questions? Yes, sir.
In the general 3D printing community, there are various sites like Thingiverse, etc., which have a lot of already made stuff. Is there one for aquarium stuff?
Not specifically, not that I know of.
There should be, right? So that, because aquarium people all face these similar kinds of, I need a little gizmo and something to connect this to that.
So here's the trick. Whatever problem you want to solve, whatever tool or object you want, try Googling thing.stl, right? Floating feeding ring STL. Search for that and you'll find 10 people who've already made one. Yeah, but I have not found a place where 3D print files for aquariums are aggregated.
GrabCAD might have an aquarium category. They're kind of the largest or
Which one?
GrabCAD. GrabCAD. They have more than just 3D models. You'll find drawing, like technical drawings of objects and rendering. They run contests.
Nice. Any other questions? Yeah.
Try Yegi.
So what's the best way to fix something that's already been printed that has literally wavy lines, that's really fun sands?
Vapor smoothing, maybe? Sanding? Print better next time? I don't have a good answer to that. Work on your settings. Look up the problem. Look up Z-banding, for example. Find what the solve typically is. Follow recommendations. Tighten your belts and try to do better next time. Otherwise, you're stuck to cutting, sanding, or dissolving your problems away. That's high effort.
How do you resolve them?
Solvents, nasty chemicals, really nasty chemicals. Sometimes.
Good fun stuff. Did you consider in your fry rearing tank that you build like a more controllable flow option, like a really low flow peristaltic pump or something, rather than using a
I wanted air. I wanted air because everybody's got an air pump. If in a fish room, a lot of people have an air loop. It's just easy to have one set up and then a second and a third. And air is just easy. Yeah, but peristaltic, sure. Yeah.
If you wanted to really control flow rate at a finer rate, that would be the...
Absolutely. Electrically pumped water is the gold standard. You just can't do better than that. But I tried to do the very best I could with air to fake it. Yeah.
So if you actually want to print your own stuff, what do you suggest is both the best printers to pick from, and then what are the worst ones to pick from?
Really depends on I don't know. I've only used a few in my life and I just can't speak from experience to anything else, but the two that I used I would totally recommend. If you don't want to spend a lot of money, I would absolutely recommend buying it in for free, just like the one that I showed you. If you want to spend a little bit more, Bamboo Lab is awesome.
Have you got maybe the A1 or the A1 Mini? It's another bamboo, but...
Yeah. They're a little pricier, but excellent. I can just assume from the brand name they're probably really good. So Bamboo Lab is pretty good. I think we should probably call it. Yeah.
If you don't want to buy one, many of the public libraries have them available. You can just go
They
down
do.
and use them for free.
I have heard that. There's also printing services that you can pay to have you make stuff, but in my experience, just from getting quotes, they're absurdly expensive. Better off just buying your own printer. Okay, so just a reminder, if you saw the fry tray and you thought that was awesome, you can come play with one. There's one sitting over here, and there are 3 donated to the club for the auction if you want to take one home. Thank you.